In this video, we are going to practice the process of completing the square. Now, this is something y'all did in both Algebra 1 and Algebra 2. We're just going to refresh and bring it back to your memory again because we're going to need it for some other things that we're going to do this semester. So, completing the square is a process that was developed by the Arab mathematician Al-Khwarizmi hundreds and hundreds of years ago. And when he was doing math, it wasn't done in symbols like we do now with letters and numbers. It was done in words. So this would be Al-Khwarizmi's process right here. Here's the quadratic that he's trying to solve. You can see that in his case, he does not have it equal to 0. So he took that x squared and he put it here. And he figured out the side lengths by using the geometry idea of area. In Al-Khwarizmi's day, most math was translated into a geometric idea, even if it was algebra. All right, then he took this 10x and he split it into pieces, added it around here, and then he had to figure out what this piece was going to be in order to complete the square. You can see that this one is not complete because it doesn't have any corners. So he had to add something in there to complete the square. And we're going to use his same basic idea, except we're going to simplify it a little bit, and we're just going to have to cut things in half instead of cutting them into 4 pieces. So the reason why this process exists, think about if we were going to solve this one using the factoring idea that we have already practiced. So if I subtract 17 from both sides, I get x squared plus 4x minus 14 equals 0. All right, so I need to multiply a times c. I'm going to get negative 14. So I need two things that multiply to be negative 14 and add to be positive 4. Well, I'm not going to be able to come up with anything. And this is not in the right form to do the square root method like we did in the last video because I have this x to the first term right here. We didn't have that when we did the square root method. So completing the square gives us a different way to solve this one when those other methods don't work. So when we did completing the square, if you remember what we looked at on Al-Khwarizmi's example, he did not have it equal to 0. Instead, he had it equal to a constant. And so we're going to do that as well. We're going to leave a little space right here. And we're going to put a little space right here because we have to add the same thing on both sides, right? And I'm going to put my 14 over here. So now I have x squared plus 4x represented by this shape. And I have 14 over here on the right-hand side. Okay, so let's see what's going to happen with our boxes that we have here. So the x squared, Al-Khwarizmi had that in the center. We're going to put it down here. And we're going to use his same geometry idea. If that is a square, the area of the square, base times height, length times width, but they're both the same, right? Because it's a square, all the sides are the same. So I have x and x. And then we're going to take this positive 4x right here, and instead of cutting it into 4 pieces like he did, we're just going to cut it into 2 pieces. So I've got 2x and 2x. Okay, now look at this rectangle. Do you remember the area formula for a rectangle? When we multiply to find the area of a rectangle, it's base times height, just like it is for a square, except that the base and the height are not necessarily the same. So this side is x, right, because it matches that side. If this side is x, and the area is 2x, x times this side, whatever it is, has to give me 2x. Well, that side must be 2. So I'm going to write x plus 2 down here. I'm going to write x plus 2 on this side as well because I have a positive 2x right there. So at this point, I haven't changed the value. I have x squared. 2x plus 2x is 4x. I haven't changed anything. But now I'm going to complete the square. Now I'm going to add in that part just like Al-Khwarizmi did. So this length matches this one, which is 2. And this length matches this one, which is 2. So for this square, 2 times 2 is 4. All right, so if I add an area of 4 on the left-hand side, I'm going to have to add an area of 4 on the right-hand side as well in order to keep it balanced. So let's go back to our equation, and we're going to add 4 on both sides of our equation. Okay, now I want y'all to look at what happened here. If I take this 4 and I cut it in half, I get 2, and then I square it. That's where this came from. 2 times 2 is 4, and that's what I added on both sides. Okay, so now let's complete his process. This x squared plus 4x plus 4, that's the area of this shape, right? X squared right here plus 4x, those two put together, plus 4. That would give us the area of that whole square. But if we use the area formula, do you see that this side is x plus 2 and this side is x plus 2? Base times height, x plus 2 times x plus 2 is x plus 2 squared. So this turns out to be a perfect square trinomial. Because of the way we added to get this number, we have created a perfect square trinomial, and it is always going to factor this way. It's going to be this variable, and then it's going to be this sign, and then it's going to be half of this. And it's always going to be squared because this will work out to be x plus 2 times x plus 2. In this case, x plus something times x plus something, always the same something, what we have here. And 14 plus 4 on the right-hand side is 18. Well, now this is what we did with the square root method. Now we can get back to something we know how to do. Squared and square root are inverses. I'll take the square root of both sides, and I'll remember to write plus and minus because I have two solutions. So I've got x plus 2 on the left-hand side, plus and minus over here on the right-hand side. Let's do a quick factor tree on 18. So 18, 9 times 2, 3 times 3. I'm going to circle my 3's. So what's going to come outside is 3. What's going to stay inside is 2 because 9 and 18 are composite, so we don't need to use those. Working to get x by itself, I'm going to subtract 2 on both sides. So x equals negative 2 plus and minus 3 square root of 2. And if you need to emphasize that that is two separate solutions, I've got negative 2 plus 3 square root of 2 and also negative 2 minus 3 square root of 2. I have two separate solutions for this x. So this is how the process of completing the square works. All right, let's do another one. Let's look at this one. Okay, well, this one is a little bit different. I want to be able to put x squared in this box down here, but I don't just have x squared, I have a 3. So I'm going to need to get rid of that 3. My first step is going to be to divide everything individually by 3, working to get a coefficient of 1 right there, working to just get x squared. So when I divide by 3, I've got x squared plus 6x plus 4 equals 0. Okay, now I'm ready. I've got it in the right form. I can do Al-Khwarizmi's method. I'm going to subtract 4 from both sides. All right, so I've got x squared plus 6x plus, I'm going to leave a space right there, equals negative 4, and I'm going to leave a space right there as well. Okay, let's fill in the box. So my 6x, I'm going to have to cut it in half. I'm going to put half here, and I'm going to put half here. All right, so now let's do our side lengths. Well, if the square has an area of x squared and the sides of the square are the same, that must be x and x. And if this rectangle is base times height, and I already know the height is x, the base must be positive 3. And the same thing on this side because it's a square, so it's going to be the same. And I've got that negative 4 on this side. Okay, so now let's complete the square. Let's fill in that missing piece. 3 times 3 is 9, and I'm going to have to add 9 on both sides. If I add a square on this side of area 9, I have to add a 9 on the right-hand side as well to keep it balanced. So I'm going to have plus 9 on both sides. Okay, so remember, this is one way of writing the area of the square using all the little pieces, x squared plus 6x plus 9. And I want to rewrite that using the factored form, using the base and the height that I have written out here. So that's going to be x plus 3 squared. Because if I did x plus 3 times x plus 3, if I FOILed those together, this is what I would get for my answer. This is a perfect square trinomial. Equals negative 4 plus 9 is 5. Okay, so now I can use the square root method. Now I'm going to take the square root of both sides, remembering to write plus and minus. On the left-hand side, I just get x plus 3. On the right-hand side, plus and minus the square root of 5. And 5 is prime, so we don't need to do a factor tree on that one. I do need to get x by itself, though. I'm not finished. I need to subtract 3 from both sides. Usually we put the constant term first and then the square root behind it. So it looks like that. And remember, that is two solutions. The first one is negative 3 plus the square root of 5. And the second one is -3 minus the square root of 5. And you could type those both in your calculator. Those are real numbers. You could type those both in your calculator and get a decimal approximation, which remember we said before, that means that this original parabola, if I were to graph it, is going to cross the x-axis 2 times because it's equal to 0, cross the x-axis at -3 plus the square root of 5 and -3 minus the square root of 5, whatever those decimals work out to be. Okay, let's take a second and let's write all the steps down. Okay, so pause the video after each one of these so that you have time to write. The first step is if a does not equal 1, like that one we just did with the 3, the first thing you have to do is divide everything by a. I have to have just plain x squared, 1x squared at the beginning. All right, second step, rewrite the equation so that c is by itself. That means move the c to the other side of the equals. Add it or subtract it, whatever you need to do to get it over there. All right, now this is where we took half of it. Remember we took half of it and split it between the two boxes, and then we squared it to get that other box. So that's what's happening here. I'm taking half of that middle term, and then I'm squaring it to get what goes in the box, and add that to both sides. I rewrote it as a perfect square trinomial in factored form. So this is where we did x, the variable, with the sign, and then half of that b term, and always it's going to be squared. And then we solve by the square root method, which we have already practiced. Okay, pause the video so you can get all of those steps written down so that you have them to refer to while you're working on your homework. All right, let's do this one using the steps. We're not going to draw a picture this time. We're just going to use the steps. Okay, so step 1 says if a does not equal 1, and I can see that a does not equal 1, so I'm going to divide everything by a. So that means each term individually, I'm going to divide by a, which in this case is 2. Oh, that's a terrible looking A. Okay, now the second thing says rewrite the equation so that c is by itself, which means I need to move this over to the other side. So I'm going to subtract 4 on both sides. So I get x squared minus 8x. I'm going to leave a blank right there, equals -5, and I'm going to put a blank on this side as well. All right, now add b over 2 squared. So that means I'm going to take half of this one, just like we did. Remember, we split it between the two boxes. Half of -8 is -4. And if I square -4 times -4 is +16. And that's what's going to go in both of my blanks. All right, now I'm going to rewrite the left-hand side using this. So I've got x. Now this says plus b over 2, but think about what b is in this case. B is -8. So if I add -8 over 2, that adding a negative is the same thing as subtracting. All right, and 8 over 2 is 4, and that's going to be squared, because remember this is a perfect square trinomial, so we're just writing it in factored form. All right, -5 plus 16 is 11, simplifying that side. And now step 5 says to solve this by square root. So I'm going to take the square root of both sides. Remember to write your plus and minus. On the left-hand side, I get x minus 4. On the right-hand side, I get plus and minus the square root of 11, adding 4 to both sides. So x equals 4 plus and minus the square root of 11. And if you need to write that as two separate things, I get 4 plus the square root of 11 as the first answer, and 4 minus the square root of 11 as the second answer. Okay, so look at our original quadratic. Our original quadratic this time is not set equal to 0, it's set equal to -2. So that means if I graphed this parabola and I graphed the horizontal line y equals -2, those two things would intersect in two places, and the x value of those intersection points would be whatever this decimal works out to be. So if I type this into my calculator and got the decimal, that would be the x value of my intersection points.